polynomials. We'll get into multiplying next week, which is a little bit different. So we're going to identify and write polynomials using standard form and add and subtract polynomials. Those kind of all go together. So when you add and subtract them, you're going to write your answer in standard form, which is very basic. So a polynomial is a monomial. We were dealing with monomials last unit. That was with all the exponents. As long as it was a single term, that's a monomial. So a polynomial is one or more, or a sum of two or more monomials. And then some of them have a special name depending on how many terms that they have. So a monomial is one term. It can be just a number. It can be just a variable. It can be a combination of numbers, variables, exponents, as long as there's no addition or subtraction, it is one term. And it should not be divided by anything, so there should be no fractions really. A binomial, the prefix bi means two, so that's two monomials. So if you've ever seen x plus 3, that is a binomial, because it's two terms being added together. A trinomial would be 3. Now anything past a trinomial is just called a 4-term polynomial, a 5-term polynomial. So those don't have special names, just these 3 do, but the prefix poly means many, which means at least one. Technically a monomial is a polynomial, but generally we refer to that as multiple. Now we're going to be talking about degree of each term. So the degree of a monomial, which is the single term, is the sum of the exponents of all its variables. Now if it has different variables, you're not doing anything to it, just to determine the degree, but you would add up all the exponents. A non-zero constant term, so meaning a number, 1, 2, 3, 4, has a degree of 0 because there's no variables attached to it. And 0 has no degree at all, but that won't come up very much. The degree of a polynomial as a whole is the greatest degree of any term in the polynomial. You can find the degree of a polynomial by finding the degree of each term. Polynomials are named by their degree. Now they're named based on this chart. So if it is a degree of 0, meaning a number, okay, so the number 5 has a degree of 0, that is a constant. Now we've been using constant before. That's why it's called a constant, because it has a degree of 0. If it has a degree of 1, meaning the highest exponent is a 1, so when we have x to the first power, that is a linear monomial. Now we talked about linears, that was actually on your test yesterday, but when you graph a linear, it's a straight line. But what makes it linear, bless you, is an x or any variable to the first power. Now the second power, or the second degree polynomial, if that's the highest exponent, that is called a quadratic. That is largely what we're dealing with this unit and into next unit. They're called quadratics. 3 would be a cubic, 4 would be a quartic, 5 would be a quintic, and then anything higher than that does not have a special name. 6th degree, 7th degree, 8th degree, and so on. Okay. So we'll be practicing with those a little bit, but these names express the highest degree. Okay, we're going to practice on it on the first one. Now, where was I? Addition is commutative, so once we get into adding and subtracting in examples 2 and 3, the terms of the polynomial can technically be written in any order. If you need to see them next to each other, we're going to be combining like terms when that happens. The standard form of a polynomial has the terms written in order from greatest degree to least degree. So all your answers need to be written like that, and we're going to do that several times today. When a polynomial is in standard form, the coefficient of the first term is called the leading coefficient. So that's a lot of information. It's just stuff that we're going to be using, and you'll hear me say those words several times. Okay. So, any questions before we go into the examples? Okay. So the first example, I only did one, but if you have any questions, let me know. So right now we have 4x plus 12 plus 2x cubed minus 3x squared, and we need to write that in standard form, which means highest degree to lowest degree, which would be highest exponent term to the lowest one. So what's the highest exponent you see? 3. So the term 2x cubed would go first in standard form. Okay. Followed by the next highest, which would be what?
Then 2.
Then minus 3x squared. So since it's negative 3x squared, no matter where you move it, that needs to stay at negative 3x squared. Okay. Followed by what?
4.
4x, since that's positive, it stays that way, followed by 12. So degree-wise, this first term has a degree of 3, because that's what the exponent is. This term has a degree of 2, this has a degree of 1, this has a degree of 0. Think about it as an x to the 0 power, which is just 1. Okay. Now you may not always have third degree, second degree, first degree, and 0. As long as they're in order, you might have fifth degree, and then it jumps to an x squared, and then it jumps to an x. As long as it is in what's called descending order, so highest power to lowest power, these are what all your answers should look like. Okay, highest degree first to lowest degree. So this is part of this answer for this one. So this is the first part where it says write it in standard form. That's what standard form is. It's called descending order. Yeah.
Why is 2x cubed first? Isn't negative 3x squared a bigger number than 3x?
X cubed is the highest exponent. That is degree. It has nothing to do with the numbers in the front. It's based off the exponents, yeah. Because otherwise 12 would go first.
And if there weren't exponents, then what would you do just based off the number? For like 4x and 12?
So you would always go from highest degree to lowest degree. So this technically has an exponent of 1. That would be like a 12x to the 0 power. So it's highest exponent to lowest in all of your answers. That's what standard form is, or descending order is what that's also called. Okay. We're going to be doing it several times today with descending order, but that's what all your answers, this whole unit and beyond, need to look like. Highest exponent to lowest. Okay. Now, the leading coefficient. So we did the first part of the instructions. The leading coefficient, what's a coefficient? So this is the leading term. So when it says identify the leading coefficient, this is the term at the highest degree. What part of this term is the coefficient? 2. It's the big number in front of it. Okay. The coefficient of this one would be -3. Coefficient of that one would be 4. This one's just a constant, so technically it doesn't have a coefficient, but it's the big number in front of all the variables. So since 2 is the big number on the first term, the leading term, that is the leading coefficient. So for that one, we would say leading coefficient is 2. Because that is the big number in front of the x cubed, which is the highest degree term. So this is kind of like 3 examples in one, but we're going to classify the polynomial by its degree and number of terms. So the highest degree was what?
2x cubed.
Right, so the highest degree is 3. What's a degree of 3 called in that chart? A degree of 3. Cubic. Okay. So this is a cubic. How many terms are there? 4. Okay. 1, 2, 3, 4. Does a 4-term polynomial have a special name?
Nope.
No. It stops at trinomial, which is 3. So we would just call it a polynomial. Okay. So this would be a cubic polynomial. If it had 3 terms, it would be a cubic trinomial. If it had 2 terms, it would be a cubic binomial. Okay. So it's the highest degree is the degree name. The nomial, whatever it is, tells you how many terms there are. If you want to be super specific, you could say cubic 4-term polynomial, but the book's not going to require that. Just polynomial is anything higher than 3. Okay. So use that chart, okay, but it's constant, linear, quadratic, cubic, quartic, and quintic. And after that, it's just 6th degree, 7th degree, 8th degree. Those aren't special. Lizzie.
So anything bigger than 3 is a polynomial?
Yeah, which just means many terms. Okay. So it's a monomial, that's 1 term, binomial is 2 terms, trinomial is 3, polynomial is anything more than that. Okay. So that was almost 3 examples in one. We're going to do the standard form, writing it in its order on every single problem because all your answers need to be in that order. Okay, there's no gray area there. That's how they need to be. Okay. So now we're going to go into adding and subtracting. Is there any question before we do so? Yeah.
Why does it have parentheses?
Down here?
Yeah, I'm so, like,
Well, I'm gonna explain that. So is there any questions before we get to those? Okay. Now adding and subtracting. Now the reason there are parentheses is because this is a polynomial added to another one. So on this one we would be adding a binomial plus a binomial. This would be a trinomial plus a trinomial, binomial plus a trinomial, so it's just separate polynomials. Now in adding, the parentheses are not actually necessary, because all we are doing is combining like terms with adding. Okay. With subtracting, there's something we have to deal with first, which we've done a little bit of before. Okay, so we've done combining like terms before, yes?
yes.
Okay, I guarantee you have. We have in here. It's just probably been a little bit. So with adding, okay, the parentheses are not actually necessary, so you can somewhat ignore them. Now start with your highest degree. So in A, what's the highest exponent you see?
3x squared.
So x squared.
Yeah.
Okay. Now we have more than one of them, so you will combine them as they are. So what is 3x squared plus a 1x squared? 4x squared. Since that is the highest degree, that will go first. Okay. Now what we're left with is a -4 and a -9. Are those like terms?
Yeah.
Yes. Okay. If they weren't, then you would just keep them separate, but I have many different examples of these. But since they are like terms, you combine them as they are. So what is -4 plus -9? -13. So -13. That's it. Okay. For adding, the parentheses are not necessary. For subtracting, they are. So that's the difference, but we'll get to that in a few minutes. Okay. So on all of these, start with your highest degree because it has to be in that order anyway. Okay. So on B, what's the highest degree we have? X squared again. Now, if you don't see a number in front, there is a 1 there. Okay. So this is a -1x squared plus 2x squared. What's -1 plus 2? 1x squared. It is up to you if you want the 1 or not. So you can write a 1 here. It's not gonna hurt anything. I will tell you the book won't have it there, but it is there either way. Okay, so 1x squared. Now, as you're combining like terms, if there's a lot of them, so you'll notice some of these down here get a little bit lengthier, you almost cross them out as you go, just to make sure you got them all. So, if that helps, do it that way. Okay. Or, I've had students before, they'll circle a couple sets of like terms, then they'll box another, and then they'll underline another. So, whatever makes more sense to you. If you have multiple highlighters, you can do that. Okay, to identify your like terms.
Are we not adding the exponent to and 2?
No. So that is if we were to multiply the two, which next week we'll be doing some of that. That is where we bring in those exponent rules you were just tested on again. That is why you would learn them in the first place. So when just combining like terms, the variables stay the same. It's the coefficients that change, which is the big numbers. Okay. So we have our degree of 2. What follows that? What's the next highest?
4x.
The 4x. Does it have a like term? No, it's the only one that's 4x, so just put it in its proper order, plus 4x. We're done with that one. And then we are left with +8 minus 9, -1. So 4x doesn't have a like term, that's fine, just put it in its proper order. Okay. So we have simplified it into one polynomial. You should have no like terms. Everything should be in what's called descending order, which is standard form. Okay. All right. What's your highest degree on this one? The y squares. Okay. So I'll do it the shape way that I mentioned. 20y squared plus a -13y squared. What's 20 minus 13?
7.
7. So we have a 7y squared. Okay. Next highest degree would be what?
The y.
The y to the first power. So I have 12y plus 1y. 13y. And then last I have -2 minus 10. -12.
Yay,
we're getting a little bit easier.
Yeah.
Yes.
Okay.
Very.
Alright, let's try D. I want you to try it on your own. Start with your highest degree and work your way down. Anyone have an answer? If you're still working, keep working. Lizzie, what do you have?
3f cubed plus 6. Wait, I think I messed up something.
You're doing okay.
Oh wait, it's 6f cubed.
No,
Minus 2f plus 5.
this is correct so far.
Wait.
Marilyn?
3f cubed plus 6f squared minus 2f equals, no, plus 5, sorry.
Yeah, that's what I had.
What's up?
Yes. That is correct. Okay. So this one, the highest degree was 3, but it had no like terms. So the f cubed just goes first because it's highest degree. Okay. So this was kind of its own, since it has no like terms, but it's still highest degree, it goes first. Okay. Then we have f squareds. So we have 5 plus 1 is 6. Now be careful in these, -1f and -1f is a -2f. Okay. And then the 5 is by its lonesome and that goes on the end. Okay.
Are we ready?
So with adding, the parentheses are unnecessary. Okay, I'm about to explain why, because subtraction they are. Okay. There's only one difference between adding and subtracting. But your last step of the subtracting is just like this. Okay, which is why we started off with adding. So any questions on any of those 4? Okay. Subtracting. The reason these parentheses are necessary is I already covered up this first set. What number is in front of the parentheses?
-1.
There's a -1 there.
Do we have to distribute?
Yes.
Oh.
Okay. So the primary difference, there's a -1 here, which you will need to distribute to whatever follows. Now, on the adding ones, could we technically distribute a +1? Sure. Is it gonna do anything? No. Okay. A +1 times x squared is still a positive x squared. A +1 times -9 is still a -9. So no sign changes happen, which is why adding, you can kind of ignore the parentheses. But subtracting, you do have to distribute that minus sign, which is technically a -1. Now, all it's gonna do is change the signs of whatever follows. Whatever's positive will become negative. Whatever's negative will become positive. Now, the first set of parentheses, those are unnecessary. So that will stay as 6x minus 11. Now this will be minus a 2x and a plus 19. So it will change the signs of whatever it's being distributed into. It's the only thing that happens. Okay. Now next week we'll be distributing more than just a negative sign with it. So yes, that will change things. But with just today, it's either going to be adding, which is just combining like terms right away, or subtracting, which is distributing a negative sign and then combining like terms. Okay, so now this is where we were when we were adding. So what do we combine first? 6x and -2x, which is 4x. Do not change the signs when you're combining like terms. Just leave them as is. And then -11 plus 19.
Is it 8?
Yes. Okay. Now, if you struggle with just adding and subtracting, yes, use a calculator to make sure you get your numbers right. I know a few of you have them. Hopefully we can do some math in our head, but generally the most common mistake I see on these, sadly, is not being able to add, subtract, and multiply properly. Okay. So, final answer for this one is 4x plus 6. So it just adds one additional step at the beginning of distributing that minus sign. Other than that, they're very similar to the adding ones. Okay. So again, over here, you distribute the minus sign into the parentheses after it. So we still have x plus 2. Now what? Also, most common mistake I see a lot, not distributing that all the way. So leaving a sign when it should be changed. So these two, the 7x and the 14 were positive, now they're negative. This one was negative, now it's positive. So they should be complete opposite signs of what they started with. Okay. And then we combine like terms. What goes first?
3x squared.
The 3x squared. It has no like terms, so we're just going to leave it. It goes up front. What follows that?
Minus 6x.
Good. Negative 6x, because we have a 1x minus 7x. 1 minus 7 is negative 6. And then we finish with positive 2 minus 14.
So negative 12. Wait.
Negative 12, yes. Okay. How are we feeling? Okay. Take your time on these. They should not take you very long. We're going very slow. But, again, I see common mistakes if you're rushing. So let's try the last two. I'll give you a little bit of time for that. Distribute that minus sign first into the second set of parentheses. Okay. On both of them. Then combine like terms starting with your highest degree and working your way down. You have a question?
Yeah, so when there's no like big number, so on G,
Mhm.
like there's Z2 and then there's 3Z2,
Mm-hmm.
do you combine those still?
After you distribute the minus sign, yes.
Okay, but
Mhm.
so would it be 4Z2 or just 3Z2?
Well, when you distribute, it would be plus,
Yeah.
so it would be 4. Are we getting a little bit faster?
Yeah.
So who has an answer for G? Marilyn?
Is it 4z squared minus negative 7z minus 5?
We agree?
Yes.
So after distributing, you should have z squared plus 2z minus 5. So the first one's unaffected. Minus 9z, then plus 3z squared, because you would have double negative technically. Okay. But just change the signs. That's all the negative really does. The z squared plus 3z squared is where the 4 came from. 2z minus 9z is 7z, minus negative 7z. And then the 5 has no like terms, so minus 5. And I just write my z's like this so they don't look like 2's. But if you write your z's better than me, you don't need the line there. Anyone have an answer for H? Alice.
Negative 6h to the second power, plus 7h, minus 2.
We agree?
No.
No.
Jason, what did you do?
Oh, I was just like kind of doing it. Hold on. Okay, I have negative 6h to the second minus 9h. Then plus 2.
Me too. Yeah, I got that.
Anything different? So we all have one of those on our paper? Alright, so after distributing, first one is unaffected. Now it's minus 5h squared plus 2 minus 8h. Okay. Now starting off with, so we agreed on this part at least, these two together. Okay. Negative 1h squared minus 5h squared is where the negative 6 comes from. Okay. Now, there are 3 h's. Anyone notice that? Start with? So, another side note that you could do, since these are in the same set of parentheses, you could have combined this to a negative 1h if you wanted to. Okay. Whoa. Hello. Bounced off my watch. Okay. So, if you wanted to, you could combine these first within the parentheses if you wanted to. to get a -1h and then combine that with the -8. But if you just do all three at once, that's fine. Just go from left to right. So we have 1 minus 2, which is -1, minus 8 is -9. Just make sure to go left to right. There's less errors that way. And then plus 2 is the only 2 that's there. So this one is the answer. Alright. Now, a couple things I want you to pay attention to in your homework. You'll notice these are not as hard as you may have thought to start with. All your answers need to be in descending order, which is what standard form is. But descending order means to descend, highest to lowest. I need you to copy down the original problems, because on some of them they're just adding. It's just that and then your answer. Okay. Subtracting, I'm going to see you distribute the minus sign, combine like terms. So you should have the equivalent amount of work that we have up here. Okay? So, although it's about 20 problems, it shouldn't take you that long. Okay?